Hello students, in this video I am going to discuss about chapter 2 of class 9, that is polynomials. Now before starting, let me give you the idea about what is a polynomial. An algebraic expression of the form px equals to a0 plus a1x plus a2x square plus a3x cube, in this way up to suppose an x to the power n, where this a0, a1, a2, these are all real numbers, and this an is not equals to 0 and n is a whole number, then this type of algebraic expression is called a polynomial in variable x. Suppose if I write 3y square plus 5y minus 7, this is also a polynomial in y, so we can write here, say p is the name of the polynomial and variable is y here, so py equals to 3y square plus 5y minus 7. Now this is a polynomial as power of y is 2 here and here power of y is 1. Both of them are whole numbers, that's why it's a polynomial. In simple terms we can say, suppose we are having a polynomial where the power of the variable is neither negative nor fraction, then it is a polynomial. So we can write, in case of a polynomial, power of the variable should not be negative or fraction. Power of the variable should not be negative or fraction. If I write one algebraic expression like x plus 1 by x, this is not a polynomial. It is because it can be written as x plus x to the power minus 1. Here 1 by x can be written as x to the power minus 1. Since the power of the variable is negative, so it's not a polynomial. Let me give you another example. Suppose root over 3x plus 9. Is this a polynomial? Here if I write this one, that means the first term as root over 3 into root over x plus 9, we can write this expression in this way, which can be written as root over 3 and root over x means x to the power half plus 9. Here power of the variable is a fraction, that means it is not a whole number, so it is also not a polynomial. 5 is a number. 5 can be written as 5 into 1 and this 1 can be written as x to the power 0. So 5 x to the power 0 is same as 5, so it's a polynomial, and here the power of x is 0, which is a whole number, that means it is a polynomial. Now the next term that we should know is the degree of a polynomial. Whenever we write a polynomial, the highest power of the variable is called the degree. Say for instance, if I write 7x cube plus 5x to the power 4 minus 9x plus 3. This is a polynomial because here power of x is 3, which is a whole number. Power of x is 4, it is also a whole number. Here power is 1. So the power of variables in all the cases, they are whole numbers, so it is a polynomial. Now out of these powers, here power of x is 3, power of x is 4, and here power of x is 1. Which is the highest power? Highest power is 4. Since 4 is the highest power, therefore degree of this polynomial, we can name this one suppose px. Here variable is x, so we have to write x here. So degree of px is 4. Okay, let me give another example. Suppose it is 7x to the power 5 minus 9x square plus root over 3. Is this a polynomial? Just check. Here the variable is x, so we can name it suppose qx. Power of x is 5, power of x is 2, both of them are whole numbers, so it's a polynomial. Out of these powers, the maximum power is 5, therefore degree of qx is 5. I hope what is degree of a polynomial is now clear. The next two terms which are very important in this chapter, they are constant and variable. Now what is a constant? The symbol which has a fixed numerical value is called a constant. Suppose 7, 9, 2 by 3. These type of terms are called constants. Now what is a variable? The symbol which assumes different values in different situations is called a variable. Suppose if I consider area of a circle, we know area of a circle is pi r square. Area of a circle formula is pi r square. Here r is the radius of the circle. In this case pi is constant while r is a variable. If radius of a circle is 1 centimeter, then r will be 1. If radius of a circle is 2 centimeter, then r will be 2. If it is 5, then r will be 5. That means in different situations, r will have different values. That's why it is called variable. But in all the situations, value of pi is same. That's why it is called constant. In case of circumference of a circle, we can write 2 pi r. Here, this 2 is constant, pi is constant, and this r is the variable. R is the variable, and this c is also variable. Now, if radius equals to 1, then circumference will be 2 pi into 1, that is 2 pi. If radius equals to 2, then circumference will be 2 pi into 2. 2 to the 4 pi, it will be 4 pi. So if I take different values of r, we are going to get different values of circumference. So here circumference is also a variable, radius is also a variable, but 2 and pi, these two always have the same value, so these two are constants. What is an algebraic expression? Combination of constants and variable by the use of sum or all operations like plus, minus, into, division is called an algebraic expression. If I write twice x plus 7, this is an algebraic expression. X plus 1 by x, this is also an algebraic expression. Root over x plus 7, this is also an algebraic expression. Out of these three examples, this one is a polynomial, but these two are not polynomials, though they are algebraic expressions. That means all the algebraic expressions are not polynomial. If the power of the variable is a whole number, then only we can term those algebraic expressions as polynomial. What are terms in a polynomial? If I write a polynomial like 7x cubed minus 5x squared minus 9x, here 7x cubed minus 5x squared minus 9x, these are called terms of this polynomial. In this polynomial, this is one term, this is second term, and this is the third term. So 7x cubed minus 5x squared minus 9x are the terms of this polynomial. Next term is what are coefficients? Coefficients means if I write this expression again, 7x cubed minus 5x squared minus 9x plus 3 suppose. In this polynomial, there are 4 terms. First term, second term, this is the third term, and this is the fourth term. So what is the coefficient of x cube? Here coefficient of x cube will be this 7. It is 7. Coefficient of x square. So here coefficient of x square is minus 5. Right here minus 5. Now what is the coefficient of x? So coefficient of x will be other than x, whatever left in this term. Other than x, it is minus 9. So minus 9 is the coefficient of x in minus 9x. Minus 5 is the coefficient of x square. And 7 is the coefficient of x cube. If I write one expression like 7x square y, in this case, coefficient of y will be 7x square. Coefficient of x square will be 7y. And if it is given numerical coefficient, in that case we have to write numerical coefficient of, suppose it is y. Now numerical coefficient of y, if I say coefficient, it will be 7x square. Since I have used the term numerical, then we have to consider only the number, that is 7. There are different types of polynomial depending on degree. If degree is 0, then it is called constant polynomial. Say for instance, if I write 5 can be written as 5 into 1, and it can be written as 5x to the power 0. Since here degree is 0, then this type of polynomials are called constant polynomial. Suppose degree is 1, 7x plus 2. Here power of x is 1. Since maximum power of this polynomial is 1, so it is called linear polynomial. We can write example like 2x minus 3. Here also degree is 1. Suppose degree is 2, then it is called quadratic polynomial. Quadratic polynomial. Suppose x square minus 9x plus 5. Here power of x is 2 and here power of x is 1. Since maximum power is 2, so this is a quadratic polynomial. If it is 3, that means degree is 3, then it is called cubic polynomial. We can consider the example like 3x cube minus 5x plus 2. In this case, maximum power of the variable is 3. When the degree is 3, that is called cubic polynomial. If degree is 4, then it is called biquadratic. Biquadratic polynomial. We can write example like x to the power 4 minus 9x minus 2. Here degree is 4. Since degree is 4, so this is an example of biquadratic polynomial. We can also classify polynomials on the basis of number of terms. Suppose a polynomial which has only one non-zero term, then it is called a monomial. If I consider the example like 7x or 2 by 3y or suppose 5, these type of polynomials are called monomials because in all the cases only one term is involved. Suppose a polynomial is there which has two non-zero terms, then it is called a binomial. We can consider the examples like 7x minus 5, 2x square minus 9, or say 3x cube minus 5x. Here how many terms? 2. Here how many terms? 2. Here also 2 terms. So these are all examples of binomial. A polynomial which has 3 non-zero terms, then it is called a trinomial. Say 5 plus 9x minus 9x square, or you can consider x to the power 4 minus 3x plus 5. In these two polynomials, there are 3 terms. First term, second, third. Here also first, second, third. Since in these two examples, there are 3 terms, so these are called trinomials. So these are examples of monomials as they contain only one non-zero term. Here these are binomials and these are trinomials. A polynomial which consists of only 0, then these type of polynomials are called zero polynomials. Now in case of a zero polynomial, degree is not defined. We cannot say degree is 1 or 2 or 3. So we generally consider that degree of a zero polynomial is not defined, or we can say undefined. Now I'll show sums from exercise 2a. Here first question is, which of the following expressions are polynomials? And here some questions are given. Let me discuss one by one. In question number 1, it is given that x square minus 5x plus 7, and we have to check whether it is a polynomial. Here, since the variable is x, and here the power of the x is 2, here power of x is 1. Since this 1 and 2 are whole numbers, so it's a polynomial in x, and here degree is 2, so it's a polynomial. It is a polynomial, and we can write degree is 2 here because the maximum power of the variable is 2. In the bracket you write degree equals to 2. Now in question number 2, it is given x cube minus 5x square plus 9x plus 11. Here power of x is 3, power of x is 2, power of x is 1. All these are whole numbers, so it is also a polynomial. Just write it is a polynomial. And what is the degree in this polynomial? Here maximum power is 3, so degree equals to 3. In third case, it is given 5 root over x plus 11, which can be written as 5 x to the power half. We know root over x means x to the power half plus 11. Here power of x is a fraction. Since it is a fraction, so it's not a polynomial. It is not a polynomial in term 5 root over x power of x is a fraction. That's why it is not a polynomial. So 5 root over x plus 11, this root over x means x to the power half. We know that power of the variable should be a whole number in case of a polynomial. Since it is not a whole number, therefore it is not a polynomial. 2 cube root of x plus 11. Here also it is 2 x to the power 1 by 3 plus 11. so it is not a polynomial, as power of x is a fraction. In the same way, you can write here it is not a polynomial because in the term 2 cube root of x, power of x is 1 by 3. In next question, x plus 5 by x plus 2, it can be written as x plus 5 x to the power minus 1 plus 2. Instead of 5 by x, we can write 5 x to the power minus 1. Since power of x is minus 1 in this term, therefore it is not a polynomial, because we know power of the variable in case of a polynomial is a whole number and minus 1 is not a whole number, so it is not a polynomial. It is not a polynomial. In sixth case, it is given x square plus 5 plus x to the power 4 plus x to the power 3. Here power of x is 4, 3, 2. Since all these are whole numbers, so it is a polynomial. So we can write it is a polynomial. And here maximum power of the variable is 4. Therefore degree equals to 4. Now in question number 7, it is given minus 11. Since it is a constant number, we can write minus 11 into 1 and minus 11, and instead of 1 we can write x to the power 0. So it is a polynomial of degree 0. So we can write it is a polynomial. It is a polynomial and degree of this polynomial is 0. In this case also it is a constant polynomial because 5 by 6 is constant. Pi is also constant. So it can be written as 5 by 6 pi into 1, and we can write 5 by 6 pi x to the power 0. So it's a polynomial and degree here is also 0. In the next sum, it is given 0x square plus 0x, which is equals to 0. That means it is a 0 polynomial, and we know in case of a 0 polynomial, degree is undefined. So this expression is a polynomial. It is a polynomial of degree which is undefined. I hope these sums are clear. Let me discuss question number 2 now. Now in question number 2, we have to find the degree of each of these polynomial. In the first case, variable is x and the maximum power of x in this polynomial is 1. Therefore, degree in this case is 1. In this case, power of x is 2 and here power of x is 1. That means degree is 2 because we know degree is the maximum power of the variable. In this case, maximum power of the variable is 3. So degree equals to 3. In this case, maximum power of the variable is 4. So degree equals to 4. In this case, here you cannot see any variable because 7 is a constant number. It can be written as 7 into 1. And we know 1 can be written as 7 x to the power 0. Since here power of the variable is 0, therefore degree equals to 0. In case of pi, pi is also a constant number. Pi can be written as pi into 1, and this 1 can be written as pi x to the power 0. Since power of the variable is 0, therefore degree in this case is also 0. Now in question number 3, it is given we have to find the coefficients. Now in the first case, it is given coefficient of x in x cube plus 7x square plus 9x plus 11. So here coefficient of x is 9. Therefore, we can write answer is 9. Suppose if you take example like this, x to the power 4 minus 6x cube minus twice x plus 5, and we are asked find the coefficient of x cube. In this case, answer is minus 6. So this is the coefficient. So coefficient of x cube is minus 6. I think rest of the sums of question number 3 you can do it yourself. Let me show question number 4 now. In question number 4, it is given classify the following polynomials as linear, quadratic, cubic and biquadratic. In case of 3x minus 5, the degree is 1. Since degree is 1, that means it is a linear polynomial. Here degree is 2. Since degree is 2, degree equals to 2. So it is quadratic polynomial. Here variable is x, the maximum power of the variable is 3. Since degree is 3, so it is cubic polynomial. In case of 5z, z is the variable and power of z is 1, so degree is 1. Since degree is 1, so it is linear polynomial. And in the last case, t square plus 9, here the power of t, which is the variable in this case, is 2. So degree is 2, and when degree is 2, then it is called quadratic polynomial. Let me discuss question number 5 now. In question number 5, it is given, which of the following expressions are polynomials in one variable and which are not. Now in the first case, 3x square minus 4x plus 9, here only one variable, and the power of the variables, here it is 2, here it is 1, so it's a polynomial in one variable, polynomial in one variable. The second case, y square plus root 3, here variable is y, power of y is 2, which is a whole number, so it's also a polynomial in one variable. 3 root over 2 plus t root over 5, it can be written as 3 t to the power half plus t root over 5. And as you can see, power of t in this case is fraction, it is not a whole number, so it's not a polynomial in one variable. In case of y plus 3 by y, it can be written as y plus 3y to the power minus 1. Since here power of y is minus 1 and minus 1 is not a whole number, so it's not a polynomial. In the last case, it is given x to the power 10 plus y to the power 5 plus t to the power 60. So these 10, 5 and 60 all are whole numbers, so it's a polynomial. But in the question it is given whether they are polynomial in one variable, but as you can see here, one variable, y is another variable, t is another variable, that means there are three variables, that means it is not a polynomial in one variable. We can write here it is not a polynomial in one variable. I hope this question is clear. Let me discuss last question from this exercise, that is question number 6. In question number 6, it is given example of a monomial of degree 11. Monomial means there should be only one term and it is given degree is 11, so we can write 6x to the power 11. It's a monomial and degree of this one is 11. In the second case, it is given binomial of degree 23, so we can consider y to the power 23 plus 5. Here two terms are there, so that means it is binomial and degree is 23. In third case, it is given trinomial of degree 7, so we can consider suppose t to the power 7 plus t minus 3. How many terms are there? 3 terms, one term, second term, third term, so it's a trinomial. And what is the degree of this trinomial, which is also a polynomial, is 7. I hope sums of 2a are now clear. In my next video, I am going to discuss about zeros of a polynomial and I am going to discuss sums of 2b. Till then, bye bye, take care and wait for the next part.